I'm working with a dataset. It has 10 features, which we'll call X, and a single target variable, Y. This target variable is binary, meaning it can only take on two values, like 0 and 1, representing different classes. This is a common setup for classification problems. These are the results from using a mutualinfoclassif function, which calculates how much information each feature gives about the target variable, Y. Each number represents a feature's score. Higher scores mean that feature is more helpful in predicting the target. A score of 0 means that feature doesn't help at all. These are the actual mutual information scores. For example, the first feature has a score of 0.0, the second feature has a score of 0.8, and so on. I will use these scores to decide which features are important for predicting the target variable. This is where I interpret the scores to understand how important each feature is in predicting the outcome. Remember, higher scores mean more important. This is the core question of the quiz. I'm given 4 statements and I need to decide which ones are correct based on the mutual information scores. This statement claims that feature 1 is the most important. I need to check if this is true using the scores. This statement says that features 0, 3, and 7 are equally unimportant. I'll examine their scores to see if this is true. This statement compares the importance of features 4 and 5. I need to compare their mutual information scores to see if they are similar. This statement asks if at least 3 features provide a significant amount of information that helps in classification. I'll examine the scores to see if at least 3 are above some reasonable threshold. This refers to the overall conclusion about which features should be selected for further analysis, after considering their mutual information scores. It summarizes my findings from the quiz. I'm working with a dataset that has 10 features, things we measure, and a single target variable. The target variable tells us what category each data point belongs to. It's a binary classification, meaning there are only 2 possible categories, like yes or no, spam or not spam. These numbers show how strongly each feature is related to the target variable. A higher score means a stronger relationship, more information to predict the category. The scores are calculated using the mutual_info_classif function from the Sklearn library. I see that features 0, 3, and 7 have a mutual information score of 0. This means they're completely unrelated to whether a data point belongs to one category or another. They add no useful information to the prediction, so I can remove them safely. I found that features 4, score 0.9, 2, score 0.8, and 7, score 0.7, have high mutual information scores. This shows these features have a strong connection to the target variable and are useful for classifying data points. In fact, there are even more features that are useful, but this option only required at least 3. That's a great observation. I see this statement claims that the first feature is the most important. Let's check the mutual information scores. Feature 1 has a score of 0.0, meaning it provides no information for classification. Therefore, this statement is false. This statement points out features 0, 3, and 7. I find they all have a mutual information score of 0.0. That means these features don't help us predict the target variable, and it would be reasonable to remove them from our model. This statement is true. The statement compares features 4 and 5. Feature 4 has a score of 0.9, while feature 5 has a score of only 0.1. That's a significant difference, so I conclude that the statement is false. This statement looks for at least 3 features with strong relationships to the target variable. Looking at the scores, features 4, 0.9, 2, 0.8, and 7, 0.7, stand out as providing substantial information gain. There are even more, but 3 is enough to make this statement true. I'm using mutual information to pick the best features for classification. It's like a detective figuring out which clues are most helpful in solving a case. I have 10 different pieces of information, features, about each item, and I want to predict whether it belongs to one of 2 groups, binary target. It's like trying to sort apples and oranges based on various characteristics, such as color, size, and weight. Here are the scores showing how strongly each feature relates to my target. Higher numbers mean a stronger connection. Features 0, 3, and 7 have a score of 0, meaning they don't help at all in predicting the target. It is like having useless clues in a detective's case. We can safely remove these features. Features 4, 0.9, 2, 0.8, and 7, 0.7, show significant relationships with the target and should be considered important. It is like these clues provide strong evidence for solving a case. There are even more, but the question asks at least 3. These are my mutual information scores for each of my 10 features. The higher the score, the more important that feature is for classification. That's incorrect. Feature 1 has a score of 0.0, which is the lowest score. Feature 4 has the highest score, 0.9, making it the most important. Nope. Feature 4, 0.9, is much more important than Feature 5, 0.1. The difference in scores is significant. We're using mutual information to figure out which features are most useful for predicting our target variable. Mutual information measures how much knowing the value of one variable tells us about another. A higher score means a stronger relationship. Think of it like this. The higher the score, the more valuable the information about that feature is. I have 10 different features, X, to consider. And I'm trying to predict a binary outcome, Y. Meaning the target can be only one of two things, like 0 or 1, true or false, etc. That's my goal. Correctly predict that Y. These numbers show how strongly each feature is related to the target variable, Y. For example, a score of 0.9 means that feature is very strongly related to whether the target is 0 or 1. These are the actual mutual information scores for each feature, in order from feature 0 to feature 9. The higher the score, the more helpful that feature is for predicting our binary outcome. I will use this list to answer the questions. This is a multiple-choice quiz. I'll use the mutual information scores to decide whether each statement about feature importance is true or false. This statement is asking whether feature 1 has the highest mutual information score. Let's see. This statement suggests that 3 features have 0 mutual information scores. If this is true, then removing them would make sense since they provide no predictive power. This statement asks if features 4 and 5 have similar mutual information scores. We'll check to see how close those scores actually are to each other. This statement asks whether there are at least 3 features with high mutual information scores, indicating they are useful for prediction. This is what I'll need to check. This is the specific function from the scikit-learn library, a popular machine learning library in Python, that I used to calculate the mutual information scores. It's a tool that does the hard work for me. I'm using a dataset with 10 features, which I'll call X, and a single target variable, Y, representing a binary classification problem. That means Y can only take on 2 values, like 0 or 1, representing 2 different classes. These scores show how much information each feature provides about the target variable Y. A higher score means a stronger relationship, so better predictability. These are the actual mutual information scores for features 0 through 9. For example, feature 4 has a score of 0.9, indicating it's strongly related to the target variable. Feature 0 has a score of 0.0, meaning it's unrelated to the target variable. I used scikit-learn's mutual_info_classif function, a great tool in Python for calculating these mutual information scores. This ranking orders the features based on their mutual information scores. Higher scores get ranked higher. I have a multiple-choice question to test my understanding of the results. It's all about interpreting the feature importances based on the mutual information. Looking at the scores, features 0, 3, and 7 each have a score of 0.0. This means they don't provide any information to help predict the target variable, so we can probably safely remove them. Features 4, 0.9, 2, 0.8, and 6, 0.7, show substantial relationships with the target. There are likely more with some information gain, but the question asks for at least 3. Awesome, I see we're working with a dataset. It has 10 features, which we'll call X, and a single target variable, Y. This Y variable is binary, meaning it can only take on 2 values, like 0 or 1, representing success or failure, or true or false. This is a common setup for classification problems. These numbers represent how strongly each of the 10 features is related to our target variable. Think of it like this. A higher score means the feature is a better predictor of the target variable. A score of 0 means there is no relationship between that feature and the target. These are the actual mutual information scores for each feature, from feature 0 to feature 9. Let's analyze these numbers to see what they tell us about the features. Feature 4 has a score of 0.9, which is the highest, implying it's the strongest predictor of the target. Features 0, 3, and 7 have a score of 0.0 each, which suggests those features are not very useful for predicting why. This is the core of the problem. We need to use the mutual information scores to determine which statements about the feature importance are true. This is the function Sklearn uses to calculate these scores, indicating how well each feature predicts the target variable. I use mutualinfoclassif for feature selection tasks all the time. It tells you which features are the most relevant in predicting the target variable.